So this time I'm going to go through the single award science paper for physics. This is the Unit 3 paper and its foundation tier. And again, these are the specimen papers that CCEA put together. So the time for this was 1 hour and 60 marks for the paper. First question says, diagram shows a circuit used by students to investigate the effects of adding batteries to a circuit. So we have battery here, then a switch, there's an ammeter here, and then a little bulb. So it says use the correct symbols to draw the circuit diagram for this circuit. So we have here the battery first, then the switch, the ammeter and the bulb, and they're all connected just in a series circuit. So we've drawn that. So if you have all 4 symbols correct, you get 2 marks, 2 or 3 symbols, you get 1 mark, and you have to have the circuit complete. Okay. So then explain one change that would occur in this circuit if more batteries were added. So because it's a series circuit, if you add more batteries, the bulb will get brighter because the voltage is higher. Or you could say the ammeter reading would be higher because there's more current. On to part C, the diagram shows a circuit used to investigate the use of switches. We have X, Y and Z, which are 3 bulbs, and then 3 switches, A, B and C. So it says which switches need to be closed to light bulb X only. So if we look at X, if we connect X up, the easiest way to do that would be to go through A here. So we only need A to be connected for X to light. Now to light only Y, if we go instead in this direction through Y, if we go straight on there, we would be lighting up Z as well. So we want to take a turn there, straight across the bottom and then up. So in this case, it is C is the only switch you want to use. Next question. Listed below are 3 situations in which heat travels. So use lines to link the situation with the method of heat travel involved. So the 3 methods are conduction, convection and radiation. And if we look at the first situation here, from the sun to a roof-mounted solar panel, so that obviously is going through the air and it's going sort of down from the sun to the solar panel. So that must be radiation. The second one, from an electrical hot plate through the base of a metal saucepan. So through the base of a metal saucepan, that's conduction through a solid. And then from the element of a kettle to heat all the water in the kettle. So that would be, as in any fluid, like a gas or a liquid, obviously, convection. Next question shows how heat is lost from a house. Calculate the percentage of heat that is lost through the roof. And you see here on the diagram, the different percentages are marked on. So the roof has no percentage on it. The walls there, 35%, through the floors, 15%, through the door, 15%, and through the windows is 10%. So when we add all those together, 35, 15, 15, and 10, we get 75. And then because these are percentages, if we take that number, the 75, away from 100, we get the percentage which is lost from the roof, which is 25%. Next, the table shows the installation cost and yearly savings for insulating 5 areas of the house: walls, floor, roof, windows and doors. And you see here there's the box missing for the percentage heat loss in the roof, and we've already worked that out in the last page. Then it says the insulation cost and then the savings per year for each method. So the payback period, it tells you, is the number of years needed to pay back the cost of the insulation. So calculate the payback period for windows insulation. So if we look at windows here, we can see that it costs £3,500 to install and then saves £350 a year. So if we take that number, the £3,500 to actually install, and then £350, so we divide by 350, that gives us 10. So the payback period there is 10 years. Next, it says use the information in the table to suggest which areas should be insulated first and explain your answer. So when we look at the table, the most heat loss is through the walls. So you could say that walls would be the first thing to insulate. Explanation could be that it's the cheapest cost, or that it saves you £140 a year. So if you were to work out the payback period, you could say it's the shortest payback. Sorry, I'm going ahead of myself. So the wall would be the cheapest one. If you look at the roof here, it's actually got the shortest payback time, £450, and saves £150 a year. So the roof will be the shortest payback period. Forgive me there. So how does insulating any area of the house save money? Well, the main reason is that less fuel is needed then to heat the house, and if you're buying less fuel, that's costing you less money. So given below are types of electromagnetic radiation and some uses. Using lines link each type with one common use. So we have gamma, ultraviolet and microwaves, and then the uses: cancer treatment, remote controls, cooking and photography. So gamma is used for cancer treatment, as we know. Visible light would link to photography, and then microwaves to cooking. The one which is missing there would be infrared for remote controls. Name a type of electromagnetic radiation used in mobile phone communications. So you could say there microwaves or infrared would work as well. Next, we've got a table with data about the first 5 planets in the solar system in order of their distance from the Sun. So we've got Mercury, Venus, Earth, Mars and Jupiter. The surface temperature, the time for it to orbit the Sun in years, the length of a day, and then the orbital speed in millions of kilometres per year. So it says state a feature of a planet that increases as distance from the Sun increases. So if we look at the table here, the temperature decreases. You can see there it's going from 350. Venus is an exception, it goes up to 480, then Earth 22, Mars minus 23 and Jupiter is minus 150. The time for the orbit increases each time, so 0.2, 0.6, 1, 1.9 and 12. So obviously the further out the planets are, the longer it takes them to orbit the Sun. So that's the answer we're looking for there, time for one orbit. Now just to check the others, the length of day doesn't really depend on how far the planet is from the Sun. So Mercury's 0.16 years, Venus is 0.67 years, the Earth is 24 hours, Mars is very similar, 24 hours 37, Jupiter is very short, 9 hours 50 minutes. And then the orbital speed, you can see that as you go further from the Sun here, the orbital speed is decreasing. So Mercury is 1,560 million kilometres per year, where Jupiter is only 413. So then state a feature of the planet that decreases as distance from the Sun increases. And as I've just said, that would either be temperature or the orbital speed. Then name 2 planets in our solar system not shown in the table. So you could have had Uranus, Neptune or Saturn. So we know there are 8 planets in the solar system, and those are the 3 that are missing. Next question shows part of the moon. It says name the feature on the moon labelled A. So this feature here is a crater, and they give you a choice: volcano, quarry and crater. So you're just picking the right one and writing it in. Name the object which caused this feature. So something in space which has basically bashed into the moon and left a hole in it, so a comet or an asteroid. And then choose 2 statements below that would be true if a much larger object collided with the Earth. So would it mean that the amount of sunlight reaching the Earth's surface would be increased? Well, probably not. It's not going to just blaze a hole through the clouds and open up the sky to more sunlight. In fact, it's going to actually cause dust and all sorts of debris to enter the atmosphere and reduce the amount of light getting through. The temperature would stay the same is not correct, because as the dust and so on enters the atmosphere, it's going to block out the sunlight, which would cause the temperature to drop. Food crops would not be affected. Well, they would be affected, because if the sunlight is decreasing, then less crops will be able to grow. So the final 2 then are the correct ones. The animal and plant species could become extinct. And of course we all sort of think of the dinosaurs as an example for that. And then E is the amount of sunlight reaching the Earth's surface would be decreased. And as I've said, that's because of the dust and debris going up into the atmosphere, blocking out the sunlight. So 2 marks for those. Next question is about sound and light, and it says they're both waves. Describe fully the differences between these two types of waves, and your answer should state what waves transfer from one point to another and how they do this. State which type of wave sound and light are, and describe any differences between these two types of waves. So we're going to start by saying that what waves are. So waves are formed by vibrations and they carry energy. They're longitudinal and transverse. So those are three potential points to begin with. Then it says state what type of wave sound and light are. So I've said here sound is longitudinal and light is transverse, and I've given a little explanation as well of what longitudinal means. So longitudinal means vibrations are in the same direction as wave travel, and transverse is the vibrations are at right angles to the wave travel. And then describe any differences in these two types of wave. So sound waves travel slower than light, and light can pass through a vacuum would be two differences you could give. So when we look at this, there are 1, 2, 3, 4, 5, 6, 7, 8 potential points there, marking points. Now if you got 5 of those, you would be in the 5 to 6 mark bracket, and assuming that your communication and scientific terms are on point, you would get 6 marks. 3 or 4 points would put you in the 3 to 4 mark bracket. Again, with your communication, you would be in the 4. And then 1 or 2 points puts you in the 1 to 2 mark bracket. Alright, part B, parking sensors on cars send out ultrasound signals and time how long the signal takes to return. This allows them to calculate the distance between the car and an obstruction, as they know the speed of sound is 330 meters per second. So use the equation then, distance equals speed times time, to calculate the distance of a car from an obstruction if the time taken for the signal to travel from the obstruction to the sensor is 0.06 seconds. So you've got here the equation, distance is speed times time. So the speed is 330, the distance is 0.06. Plug those into your calculator and you get 19.8 meters. Question 6 then. Some sources of radiation, of background radiation, are shown in the table below. Put a tick beside each source caused by humans. So we have nuclear weapons, cosmic rays, granite rocks, and X-rays from hospitals. So of course the two that are caused by humans there have to be the nuclear weapons and the X-rays from hospitals. Cosmic rays come from beyond our planet, and granite rocks are not something that we have responsibility for. They were there before us. Now the bar chart shows radiation levels in different districts of Northern Ireland, and you can see here we have radiation in arbitrary units on the y-axis and then the district on the x-axis, and the graph there shows different areas: Belfast, Derry, Londonderry, Fermanagh and Newry and Mourne, and you can see the different amounts of radiation in those different districts. So then it says how much higher is the radiation level in Newry and Mourne than in Belfast. So if we look at Newry and Mourne here, we see right off the graph it's 90, and then in Belfast it comes in at 24. So 90 take away 24 is 66. And you don't need to write the units, it's just arbitrary units. But you get 1 for the calculation and 1 for getting the right answer. Now we've got a radioactive source emitting alpha, beta and gamma radiation. Each type is stopped by a different material as shown below. So you see here the source, and then thin paper, an aluminium sheet and a lead sheet. So use the diagram to name the types of radiation 1, 2 and 3. So 1 is the one which is stopped by thin paper, that's alpha. 2, just be careful, goes all the way through the aluminium sheet and the lead sheet. You might just assume it was the stopped by the second thing, but it's not. It goes all the way to the lead sheet, so that means it's gamma. And then the one which is stopped by the aluminium sheet here is beta. So all 3 of those would have got you 2 marks, and if you only got 1 or 2, you just got 1 mark. Now we've got a line graph which shows how the power used by a washing machine changes when it's set to different temperatures. We've got the power in kilowatts here, the temperature setting in degrees C, and you can see that it's going up there. So describe the relationship shown in the graph above. So there's only 1 mark here, so we're just looking for a simple description of what's going on. So as temperature increases, the power increases. And you know, if there was more than one mark there, they would be looking for you to use data from the graph and put numbers in. So, you know, as it increases towards this number, this happens, and then after that, something else happens, and again, give more numbers. But just one mark, just a simple correlation like that. So complete the diagram below to show the useful energy changes that occur in a washing machine. We've got the energy in is electrical. One type of energy out is heat, and they're looking for you to complete the last one, which is kinetic or movement energy. Now I've got a diagram here of a plug. It says the washing machine is connected to the 240 volt mains using the plug shown with a 5 amp fuse in the diagram below. So here's the fuse, here's the plug. Use the graph in part A and answer the equation, use the graph in part A and the equation power is current times voltage to calculate the maximum wash temperature this plug will allow. So we're looking at then this part. So we have 240 volts, which is the current, that's the voltage, times 5 amps, which is the current. Sorry, I've written those the wrong way around there for the equation, but it does the same job. So it's 1200 watts, which is 1.2 kilowatts. Now, when you read from the graph away up here, 1.2 kilowatts is coming in about here. And when you read that accurately, you would see that it comes in at 60 degrees. Now, they've said plus or minus 1 for that. Question 8. The graph shows how the braking distance for a car and the thinking distance for a driver change with speed. So we have thinking distance here is this bottom one, and braking distance there is the top one. Use the graph above to describe one similarity and one difference between the changes in thinking and braking distance. So the similarity is they both are going up, they're both increasing with speed. And the difference then, this one here, the braking distance, obviously is increasing much more or at a faster rate. Then a car driver travelling along a road sees a child step on the road ahead. The driver's thinking distance is 9 metres. Use the graph on the previous page to answer the following questions. What speed was the car travelling? So the thinking distance is 9 metres. We're going back here to the graph, looking at 9 metres and then across. And that gives us an answer of 15 metres per second. And then calculate the car's total stopping distance. So I've written there the answer is 27. If we go back to the graph, so we've got the thinking distance and the, sorry, I've forgotten what, it was at 9 metres. No, I've done that the wrong way around the last time, that's what it is. So the thinking distance, oh come on. It should have been here at 9, which gives the 17. So that's 17 there, and then adding on the other, we get to 27. So the total stopping distance then is adding on the braking distance as well, and that's where I got the 10 from there. So 10 and 17 is 27. Then, apart from speed, state one factor that would increase the braking distance of this car and explain your answer. So any of these, you could have said poor road conditions, poor tyres or poor brakes, and all of those then would reduce friction or grip. So you have 1 mark for the factor and then 1 mark for your explanation. Then the table shows the percentage of each energy source used to produce electricity in 73, 1990 and 2007. It also shows the total amount of electricity produced in these years. So we've got the sources here: hydroelectric, other, coal, oil, gas, nuclear, and then the total electricity generated, and that's TWH, that's terawatt hours. So, and then the different years: 1973, 1990 and 2007. So it says, name the fossil fuel that has increased the most over these years. So when we look at hydroelectric, it's actually decreased. Other has gone up a little bit from 0.6 to 2.6. Coal has increased by about 3%. Oil has actually gone down significantly, like from nearly 25 to 5.6. Gas has gone up from 12.1 to 20.9, so that's up by over 8%. And nuclear has gone up by just a little bit less than that, just 8.5. So it's gas is the one which has increased the most. During these years, the price of oil has steadily increased. What effect has the price made to the percentage of oil being used to generate electricity? Well, as you see there, oil has gone down from 24.5 to 5.6. So as the price increased, less oil was used. And the total amount of electricity generated increased significantly between 1973 and 2007. You can see there, gone from around 6,000 to nearly 20,000 terawatt hours. That's huge. So suggest two reasons for this increase. You could say there's a bigger population, more appliances, or people using appliances for longer times. So any two of those would get you your 2 marks there. And the last question then, explain fully how fossil fuels were formed. So you need to be talking about the remains of plants and animals, they died and were buried for millions of years. That's the second marking point. And then the high pressure or intense heat causes them to change. So any two of those points would get you your 2 marks. And then apart from hydroelectric, name another renewable source, wind or solar. And that's the end of that one. I will also look at the higher tier if you want to check it out as well.